call this question number 1. It's the absolute value of negative 2x equals 10. Okay. So off to the side here, there's a definition we have to provide you. So there's this absolute value function, and when it equals a number, we're going to call that number c. Okay, and this is like a function inside of here. There are two things that you have to do. Okay, there's sort of two forks that you have to always write. The first is f of x equals c. And the second one is f of x equals minus c. Now, that probably doesn't mean much to you. So let's go look at this example over here on the right. You take whatever is inside the absolute value. Okay, which is
okay.
Which is minus 2x. And you set it equal to this number. So you set whatever's inside there equal to this number on the right. That's the first thing you do. Then the other one is you take whatever is inside the absolute value and you set it equal to the negative of this number.
Okay.
So do you see in both cases we set.
Do you have to divide by 6?
No, we're not doing your problem yet. We're going to do a practice problem to build up to your problem.
Okay.
So what I want to make sure that you've heard a couple times here is that like this thing that I'm about to put in a different color here. I'm going to switch over to blue. Do you see how this minus 2x is here on the left and it's here on the left?
Yeah.
Do you see that? Okay. Now this thing on the right, which I'll show in red, it's there and there, but on this side, on the second one, it's negative.
Okay.
Okay. So now it's really one question becomes 2. Minus 2x equals 10. Minus 2x equals minus 10. To solve, you divide both sides by negative 2.
Okay.
So what is 10 divided by negative 2? Do you remember that?
10 divided by negative 2?
Yes.
Okay. 10 divided by negative 2. Okay, 10 divided by negative 2 is 5.
It's negative 5. Okay. Now on the right here, you divide by negative 2 both of them. So this time x equals 5.
Okay.
So the most important part here, because we're gonna do your problem now, is whatever is inside the absolute value, you write in both these positions, and then the number, okay, the number you write it one time as what it is, exactly what it is, and then the second time you negate it.
Okay.
Okay, so we're gonna follow that recipe, those steps for this question, this next question. So let me snip it in.
I mean, we're still in practice.
We're gonna do your question now. Okay, so I mentioned this many times. You're going to take what's here, this minus 6x, okay, and you're going to write it here, and you're going to write it over here. Whatever is inside the absolute value, you're going to write in both places.
Okay.
This 30, in one case, it's positive. You just keep it as is, but in the other, you negate it. So it becomes negative 30. Do you see that?
Yeah.
So in one case, it's positive. In one case, it's negative.
Okay. Yeah.
Okay. Now, how do you solve this equation on the left? What is keeping x from being by itself? What is keeping x from being by itself?
Keeping x to be by itself, you're saying?
Yeah.
What's keeping x? Okay.
What is in front of it? Negative 6. And it's multiplying. Do you see how negative 6 is multiplying x? So you divide both sides by negative 6.
-5.
Negative 5. X equals negative 5.
Negative 5.
Now on this other one, you're going to divide both sides by -6. So x equals, what are two negatives when you divide two negatives? That becomes positive. What is 30 divided by 6?
30 divided by 6 is 30 divided by 6 is 5.
It's 5. That's right. Great. So those are your two answers. So everything from this line down, you want to get down on your paper for this assignment.
Okay. Okay.
All right. So now we're going to do an example problem number 3 before we do number 4. So our example problem number 3 will be x over 4 absolute value equals 5. So this is actually no different than the previous problem. Okay, you take whatever's inside the absolute value. Okay, and you write it in two places. You write x over 4 equals x over 4 equals. You see how you just take that in two places? The 5, okay, you just put it in one place as is, you keep it, but in the other, you negate it. So it becomes -5.
Okay.
Are you getting this down on your notes?
Yeah, I'm getting it down.
Okay. All right. So now we have a new equation to solve. We have this x over 4 equals 5, and this other one on the right. So how do you
It's
undo?
x7, not 4.
I understand, Sourish. We're doing a practice problem.
Ah. Okay.
So if you wrote this down next to 4, this is not the right work. So let me know when you're ready to help me work through the rest of this, because this is important that you can solve this one-step equation.
Okay.
So what is keeping x from being alone? What is this horizontal bar with a 4 on the bottom? What does that mean on the left here?
Okay, so that you should multiply, is that right?
That's right. And you multiply by 4 because that's the number on the bottom.
Yeah.
So x equals 20.
X equals 20.
Yeah, I mean, these are really separate problems now, but they're part of the whole. So now it's the same step over here on the right. You multiply both sides by 4. X equals -20.
Yeah.
All right, so now let's do your problem. Okay, so I'm just asking for one practice problem in between each time. That way we can get a little bit more reinforcement of this concept. So again, you take what's inside the absolute value. That's inside the absolute value. You write it, and then you write it.
Okay, this is 7. Okay.
So what number goes in this first position here to the right of the equal sign where I'm circling? What goes there?
3.
3. And how about over here?
A -3.
-3. Perfect. So try solving this on your own from here, please.
Okay. So that's going to be x equals 21 and x equals negative 21.
Very good. Now, it may look like it, but it's not always the case that they equal the same number. But we won't see that for a while. So, all right, let's do 6. We actually don't need a practice problem for 6 because we already have had one. So we'll just jump straight to 6.
Yep.
Okay, so just like the previous problem, you're going to write minus 3p equals and minus 3p equals. To the right of the first equal sign is 15. To the right of the second equal sign is negative 15. One positive, one negative.
Yeah.
All right, so go ahead and solve it from here, please, and tell me what p equals.
Okay. P equals 5, P equals negative 5.
Perfect.
Yeah.
All right, so let me grab the next problem here before we can do 8. I'm going to grab in all 3 of these problems that we just worked on, and I want to just, there's something here that's really like critical that you can to see. Do you see how there's no other operations on the left side of 2 outside of the absolute value? Like there's not a change this here. There's not like a plus 3 equals 30. Okay, everything is like contained inside the absolute value. The second one here, like it doesn't have a number on the outside of it. Okay.
Okay. Yeah.
Like they're all like what I would call this is isolated, isolated, and isolated. Okay, so keep that in mind here. We're actually gonna do 10 first.
Okay.
So do you see that this is not isolated? What else is over here on the left side of the equation?
2.
Plus 2.
Plus
So
2.
how do you undo that?
Wait, are we now in number 10?
Yeah,
number 8?
We're gonna skip 8 for the moment.
Why?
We're gonna come back to it because this one's is hopefully easier to understand.
Okay.
So the goal here is to isolate the absolute value, but this plus 2 keeps it from being isolated.
Okay.
So you have to undo it by subtracting 2 from both sides. So when you subtract 2 from both sides, do you see that the absolute value of m is the only thing that remains?
What? Okay. Yeah.
This is important. Like in the 3 problems that we did, the absolute value is already isolated. But now in this problem, it's not isolated. This problem, it's got a plus 2. So we have to undo it. We have to get rid of the plus 2.
Okay. Yeah.
Okay, so now that the absolute value has been isolated, okay, you can say, okay, m equals and m equals. because that's what's inside the absolute value. What number goes here? 9. And then what number goes over here? -9.
-9. I was about to say it.
Good. Good. Okay, so this is all the work for number 10. Go
Okay,
ahead and get this
so
down.
all right, so okay, there we go.
Okay,
Okay.
you think do you think that you've got this down for this one?
Yep, I got it down.
Okay, so let's just say I asked you to do the absolute value of x minus 5 equals 6. Is the absolute value isolated?
Are the wait, are the
So look, this is just a new question. It's kind of like the one on the left here. Is the absolute value of x isolated? Is it the only thing on the left-hand side of the equal sign? Here's the equal sign. Here's the absolute value of x. Is there anything between it and the equal sign? What is this right here that I'm circling?
a 5. It's 5.
Subtraction by 5. So that is keeping it. That is keeping this absolute value of x from being by itself. So we can undo it by adding 5 to both sides.
Yep.
So this produces the absolute value of x equals 11. And then again, you write x equals. This number comes straight down, and then you negate it on this side here. So one positive and then one negative.
Yeah.
Okay, so before we do question 12, we're going to do one like it. We're going to do question, what I make up here, number 11. Okay, so number 11 is the absolute value of p over 2 equals.
Oh, okay. All right.
7.
So we're now in number. Wait. Are we gonna go back to number 8?
We've already. I thought we already did 8.
Did we do
Yeah,
that?
we're gonna. I'm sorry. We're gonna. Yeah, this is gonna. We're gonna do this problem, and then we're gonna go to 8. So this is one like 8. So we'll call this 7.
Okay.
So my same question to you is let me get this in the top left here. Is the absolute value isolated, or is there anything else working on it? Is there anything else causing it to not be by itself? Like what is this horizontal bar and then this 2? What is it doing?
Okay, so for that, you should for okay, so that's for practice. Okay, so for that, p2 equals 7, you should multiply that.
Yeah, you should multiply both sides by 2.
Yeah, this is easy. It's p equals 14 and p equals -14. That's the answer.
Perfect. Okay. So if you understand that, do number 8 for me. 8 is exactly the same. So I'll snip it in, but it's exactly the same as what you just said here. So go ahead and work through it on your own and let me know when you get your final answer.
Okay, so let me just, okay, so for 8, I know how to do that. I know how to do that.
Okay. You need some more time.
I need some more time. All
Okay.
right, I think I know the answer. M equals 15, M equals -15.
That is correct. So the absolute value of M equals 15. And then like you just said, you break it apart, it's 15 and -15. Very good.
Okay, and for 12, it's x equals 35,
Okay. And what's the other solution?
-35.
Perfect. Okay, so we're gonna do a problem like 14 next.
Okay.
So your 13 here is the 2 times the absolute value of x plus 5 equals let's go 6. Okay, equals 6. So my question to you, and this is very important here, is again, is the absolute value by itself, or is there something going on that's keeping it from being by itself? Like and the answer is no, it's not by itself. What is this 2 doing? What is the 2? How is the 2 operating on it? Meaning your options are it's adding, it's subtracting, it's multiplying, it's dividing. You know, what is the 2 doing to this? Is it adding, subtracting, multiplying, or dividing?
Okay, so for that, so I think you need to just add 5 plus 2.
You got to follow my questions here. What is the 2 doing to this absolute value? The multiplication operator is sometimes shown with a dot. Do you agree?
Yeah.
So what is this operator? So what I'm trying to get you to do is to say, Matthew, 2 is multiplying the absolute value of x plus 5.
Okay, x plus 5. Okay.
No,
So
I'm trying to get you to say that 2 is multiplying, because then I'm going to ask you, well, how do you undo multiplication? You undo multiplication with division.
oh, okay.
That's why I'm asking these questions, because the question leads to another question, which leads to an action or a thought. Okay, so on the left here, this is absolute value of x plus 5 equals 3.
Yeah.
So this becomes x plus 5 equals x plus 5 equals, and then here you write 3 in the first equal sign, and then this other you write -3.
Yeah. Yep.
So can you solve the rest of this? How do you undo addition by 5 in both of these?
All right. So, okay, you should multiply on those things.
Not these, because 5 is being added.
Divide by 6.
I don't think we're looking at the same problem. Are you seeing my screen here?
I'm seeing your screen. I'm seeing your
Okay.
screen.
This is x plus 5 equals 3. So to undo plus 5, you subtract 5.
Subtract 5. Okay.
Because you undo addition with subtraction. So on the right hand side, you do the same thing. You subtract 5 from both sides.
Okay. All right. X equals 2.
X equals -8.
Negative.
X, yes, it's not always negative and positive. And that's what I mentioned earlier. There's that's you know not the right way to do it. So we got to look at this answer. It's like did you understand why we divided by 2 now? Because there's a 2 in front and it's multiplying. Do you see that? Because there was a 2 in front, you divide by 2.
Okay. Yeah.
And then we do this thing that we've done a bunch of times where you write whatever is inside the absolute value. You write it here, and then you write it here. You write it out in 2 places. And then you put the number One's positive and one's negative. Because your problem is exactly like this, just with different numbers. It's the same steps.
Yeah, yeah.
Okay, so your problem right here, this is your up. This is the one you want help with. Okay. What is keeping the absolute value from being by itself? What is this 4 doing? These are your 4 options. Is it adding, multiplying, dividing, multiplying or dividing, or subtracting? Is the 4 multiplying, dividing, adding, or subtracting here?
Okay, you should subtract.
There's no plus operator or subtraction operator.
Okay. You should multiply.
4 is multiplying absolute value of n plus 8. Like there's a dot here for multiplication. So how do you undo multiplication? You undo multiplication with division. So you divide both sides by 4.
By division.
Yes. So you divide by 4, you divide by 4. You have absolute value of n plus 8. What is 56 divided by 4?
56 divided by 4. That. Okay.
So you can think of it as dividing
15.
by, I'm sorry?
It's 14, I was saying.
Yes, it is 14. Okay, now how do you solve it from here? What did we do in the previous problem? We wrote n plus 8 equals, n plus 8 equals, and then what number do we put to the right of the first equal sign? What number
14.
goes 14? What goes in this other place?
Negative 14.
Perfect. Subtract 8, subtract 8. What does n equal here when you subtract 8 from 14?
6.
Okay. Then here you do the same thing. This one's a little bit harder. They're both negative. Minus
Negative
14.
6.
It's not, it's negative 22.
Oh, yeah. Okay.
It's minus 14 minus 8. Like, and that's an easy mistake to make. It will cost you points on the exam, of course, if you do that.
All right.
Okay, so we're going to do 18 next. 18 is like really similar. It's really, really similar. Because when you look at 18, and we are going to go back and do 16, but when you look at 18, you know, these problems are fundamentally the same. Like you just do the same thing to solve this one. Okay, so what is keeping the absolute value v plus 2 from being by itself? What is this number right here that I'm circling? What number is that? Sourish, let me know when you're ready to work on this problem.
Yeah. Okay, so negative 10 divided by negative 70 is 7.
That's right. That's right. So it becomes absolute value v plus 2 equals 7. So I want you to solve from here. We've done a bunch like this. Should be able to do this one on your own. There's two equations you're going to write.
Okay. Solve two equations. V equals 5.
Okay, that's true for this equation.
Yep, V equals negative. Oh no, let me negative 5.
So you're going to subtract 2 from both sides.
Oh, thank you. Okay, yeah, V equals -9.
-9, perfect. Great. All right, so the only other problem you have on here is it's kind of like 10. Let me snip it in here, but the last problem on here that we're going to do together is let me just grab this here. Number 16.
Yeah.
Okay, so you have the absolute value x over 7 minus 8 equals -7. Is the absolute value by itself? If it's not, what is this -8 doing? What is the math operator there? I kind of just told you it's -8, but that operator is subtraction. So how do you undo subtraction?
You add.
You're going to add 8 to both sides. Very good. So on the left, it's still the absolute value of x over 7 equals, what is -7 plus 8?
-7 plus 8. Negative 15.
But this time you're adding 8. You're not subtracting.
Is it 1?
Yes. Very good. Okay, so from here, we haven't done one like this in a while, but you set whatever is inside the absolute value, you write it twice. What number goes in this first equal sign, to the right of this first equal sign?
All right, and that right there is 15.
So 1 and -1.
Yeah. Yep, that's right. Yeah.
Okay, so from here, how do you undo division by 7? How do you undo division by 7?
Undo division by 7. Okay. You should add.
You're dividing though. How do you undo division?
1 divided by 7.
You undo division with multiplication.
I'm sorry. I'm so sorry. I'm so sorry.
It's okay. I'm trying to lead you down the right process.
Okay, so division is undoing to multiplication. So multiplication, we should multiply.
Yes.
Okay. And
So what is 1 times 7?
7.
Okay. So on the other one, it's the same thing. You multiply both sides by 7.
-7.
Very good. All right. So get that down. Make sure you got all that for your assignment.
Okay. All right.
So we have some time left. Is there anything that you would like us to work on in that time?
No, I'm done. I think we finished the homework, so thank you for that.
Okay, if that's what you want to do, please check with your dad and
Yeah,
see if
Dad?
that's okay.
All right. Thank you, Matthew.
You're welcome.
Yeah.
Okay. So done. Hi.
Hey, Dr. Kithari, so we finished with this assignment. We did do practice problems in between each problem there. So we got, at least double the practice of his assignment. I always sort of ask the student, what do you want to work on when we have some extra time here? It's totally up to you guys. I'm okay to keep going, obviously. Sourish said he felt like this was all he wanted to work on today. Please let me know if you want me to continue the lesson at any time, past wherever we kind of, if you want us to go past this time.
Yeah, I think you want to do.
I'm good.
Okay, I think it's done.
Sure, sure.
Okay.
And then just to follow up to that, is this a good time for you guys? I mean, we're doing it all semester. We did all semester, but like sometimes I notice he does seem tired. I'm happy to keep this time, but is there a better time for you guys? Because you're obviously great customers. I want to make sure you're happy with the schedule.
Shari, are you okay with 6 to 7 or you want to do 78? What time is better for you? You're okay with the 6 to 7 or 6:30? Or
You know what? I know we have 7 to 8. Is that okay?
you want to do 78?
Yeah. That's maybe.
I don't know. I mean,
And for Tuesday 6 to 7 and Thursday 7 to 8.
Sure. And now next week you guys are out on Tuesday, but I'd be happy to accommodate any adjustments to the schedule if that's needed.
okay. So Thursday you want to do 78?
Yeah, on Tuesday 6 to 7.
Okay. So it's Tuesday 6 to 7, Thursday 7 to 8. Is it okay with you, Matthew?
It's fine starting next week. This week I've already got you guys down for 6.
Okay, next week we can do it. Okay,
yeah,
this week we'll do 6 to 7 Thursday. Next week we'll change that.
That works for me.
Okay, all right. Easy understanding the concept.
Yeah, I think I'm understanding. Yeah, I'm understanding.
He definitely understands. He's giving me all the right answers. Sometimes I wonder, but I think he is getting it. I'm trying to include as many extra problems to have him do more practice. Really does help him to do more. So yes, the more, even more practice be even better if there was time or interest.
Okay. All right. Yeah, I think maybe we'll do practice himself, right, Sourish?
I'm sure he's getting some in the classroom also, so that helps. More reinforcement.
Okay. All right, then. See you.
Yeah, we'll talk to you Thursday. Have a great night, guys. Bye now.
Yeah, thank you.
Bye, Sourish.
Bye.